So today we're going to talk about trigonometric integrals. Basically, integrals involving sines, cosines, and what have you, in ways in which you cannot use the chain rule in an obvious way. So, example of integral which you can use the chain rule, and I'm just making this off the top of my head, would be sine to the fifth x times cosine of x dx. Because then here you could just set u is equal to sine of x and du is equal to cosine of x dx, and then you'll end up with the integral of u to the fifth du, which is easy to do. But these types of integrals are different, and there's really not a single way to do them. It's sort of, you kind of have to think a little bit. Some of them it's not obvious at all what you should do, and I got a good amount of examples here. This video might be a tad longer than how I would like, but first I'm just gonna do examples. This video's just straight up all examples, different trig integrals. So first one, sine to the fifth x dx. Looks simple, but one thing, do not just say this is. I've seen people do this. It's u to the fifth du. No, that's wrong. The integral we had before would be u to the fifth du, because that would mean that sine is u, and du would have to be cosine of x dx, and that's not in this first integral. So can't do that. But what you do is you split up the trig functions into functions that have an even power, and then use the Pythagorean identity to replace the sign. And let me show you what I mean. So this will become sine to the fourth x sine of x dx, because we just pull a sign out. And now from the I'm just going to write the Pythagorean real quick. Cosine of x plus sine of x, and these are squared, equals 1. That's what we're going to be using here. So if we solve for sine squared, equals 1 minus cosine squared x. Okay, so now we take this integral, and well, this is sine to the fourth, but that's no problem. We could just write this as sine squared square. But then sine squared is 1 minus cosine of x. So put that in. From here we can expand. I'm just going to keep this in. It's going to be 1 minus 2 cosine squared x plus cosine to the fourth x. Now we distribute this sign through, and you'll see why we kept the sign. Let me get rid of these parentheses. Okay, now this is the reason why we pulled out one sign and made it even. If this was a 7, we would pull out one sign again and make this to the 6th power. And that's because we used the sign in the du. We make in every single, in this integral, because this is 3 integrals right here. So in this, why can't I highlight this? In this one, obviously it's negative cosine. That one's simple. This one we make u cosine. This one we also make u cosine. So if u equals cosine of x, then du equals negative sine of x dx. So Well, let's just do the integrals. I'm just gonna rewrite them. Rewriting. Integral dx and integral dx. Okay, so here's our integrals. Now we're gonna make the substitutions. This is gonna be u squared from this substitution right here, and this will be u to the fourth, and du, and now we just integrate. There's going to be negative cosine of x minus 2/3 u cubed plus 1/5 u to the fifth. But what's u? U is cosine. So we'll just change this cosine. I used to have a professor says, but we don't care about you. And I thought that was funny because it was a funny pun. Anyway, and let me just check my notes. Oh, there's one thing we forgot. Remember that this is negative sign. So when we make the substitution into the u world, these have to flip signs. That's super important. And people forget it, obviously, because I did. There.